So I think, could we factor the 3 out and try to show that the resulting polynomial is always even? So you'd have 3 times an even number is divisible by 6 because an even number has 2 as a divisor. That's the strategy that I'm thinking. I don't know if there's a better way. So I'm definitely open to suggestions on a better way to attack this problem here, but like, if I'm just being the problem on my own, the first thing I'd investigate is what happens when you factor the 3 out and then try to manipulate what results inside. So if we take the 3 outside, we get x squared plus x plus 2. And what do we know about this? It's not factorable, or at least, you need imaginary numbers or irrational numbers or something. If we completed the square, I wonder if we would get something noteworthy. What I basically want to do is prove that this part here is divisible by 2, because 3 times 2 is 6. Okay. At least for integer values. And honestly, this might be an induction thing, but I don't remember how you do induction to prove divisibility. Just thinking about it. Or maybe, okay, this is kind of weird, but if I really want to engineer something that works here, I could take these first 2 terms and factor just the x out, ignoring the 2 for now. So you get x times parentheses x plus 1 plus 2. And for any integer, if x is odd, then x plus 1 must be even. Or if x is even, then x plus 1 must be odd. Either way, you have an even number for one of these. And an even number times an odd number is still even. An even number plus 2 is still even. So this is 3 times an even number. I just feel like it's not very mathematical. That is it? Okay. Oh, good. I wasn't even looking at chat. I completely missed the last stuff that was being said. So yeah, hi Jed. It's what Thunderfix posted earlier. I do like, yeah, Zach's format is better, I think, for showing this. So instead of factoring it the way that I did, we could start back in I think I have an idea of a better way to write it out in English. Actually, wait, I mean, you're allowed to hopefully like show the equation too. But basically 6 is clearly, I mean, at least to me, it's a bit more direct if we write it in this form. So, although they both work, but 6 is clearly divisible by 6. I hope I don't have to explain that too much. And then 6 divides 6, I guess I'll write. And then for this piece, I guess we would say like in English, we have split them into cases. Case 1, we assume x is even. So x plus 1 is odd. I mean, we don't even necessarily have to consider x plus 1 here when x is even. Because we really only care about the 2 that is a factor of x and times the 3. Yes, Thunderfix. Because if x is an integer, then either x itself is even, in which case you're done, or if x is odd, you always do x plus 1. And since evens and odds alternate, that next one has to be an even. That's a good way of saying it, Jed. So yeah, if x is even, that means you're allowed to say that x is equal to 2 times some other number, n. And if you were to plug it into that piece, 3 times 2n times x plus 1, we don't care about it there. And then I can do 3 times 2 is 6n, x plus 1. And here, you don't care, like all you care about is a 6 here. 6 times anything else will always be divisible by 6. So you can say that this will also be divisible by 6. Yeah, no, it... This was tripping me up too, so... Nothing to feel bad about there. Okay, so... You know what, I did actually... Let me just send one message in Discord. Where is it? Actually, it's fine. Who cares? X plus 2 times x plus 3. Yes, because those are still two consecutive integers. As long as the difference between them is 1. Or if the difference between them is an odd number, I guess. Then one must be even, one must be odd. It was like x plus 2 times x plus 4, then they're always the same. They're always both even or both odd. That's, yeah, the book should have explained that, but oh shoot, my tea is done. 1 second. You guys can still hear me, but I just need to get the tea bag out. Oh, I never started up my music, did I? That's fine. I'll do it later when I feel like it. Where am I? Sorry for the ASMR here with silverware and all that. Just stirring in some honey, and then I'm almost done. Well, and then I am done. Come on. Okay. Usually I do all this like way before the stream, but today I didn't, so. Okay. Let's see what I missed. Oh. Yeah. If you do the same x equals 2n thing to this initial one, you would still get the 3 times 2 must divide 6 and 3 times 2 must divide 6. It's not quite as clear, but you basically plug the 2n in for each of the x's. And in this case, like you don't even care if when things get squared, because 3 times 2 times 2, which is 2 squared, times n squared, plus 6n, plus 6. So you could say like 6 times 2n squared, just to make it really clear that everything is divisible by 6. If x is odd, I assume you do the same thing, and it works out. Let's actually try that. You have a bit of math to do with that squared, but it should work out. 4n squared plus 4n plus 1. Ah, that looks ugly. Plus 6n plus 3 plus 6. And this is going to work out. Well, actually, let's bring it all the way home. 3 times 4 is 12. And squared 3 times 4 is 4n, or 12n. 12n plus 6n is 18n. 3 times 1 is 3, plus 3 is 6, plus 6 is 12. All of these are, again, divisible by 6. Hey, Pen Center. Make a fake hash function. I'll take a look. I don't know if I'll be able to do it, but... oh. Yeah, you can take either one, Thunderfix, for this context. 2n plus 1 and 2n minus 1 are both fine. You just need to be careful about where you start your n's from. So with Jed's, n starts from 1. With mine, n starts from 0. That's the only difference. Make it a bit bigger for the stream. Ah. Okay, hopefully that's readable enough. Even though it's blocking the chat a bit, it's okay. Who needs to read chat? Given that there are two distinct complex numbers z that satisfy the magnitude of z minus 3 minus pi by equals 2r intersect arg z minus 2 equals 3 pi over 4. The guy who can't read this. Two distinct complex numbers z that satisfy both of those conditions, I guess. This isn't something that I've done a lot of, but I feel like I can understand where your work is coming from here. Like, what you have here both seems like true statements. With dealing with the circle in the yeah, Pen Center. So if you want to weigh in on this, please do, because I haven't had to do a problem quite like this before. Would you take this relationship and plug it in over here? It's just the exact range of values for the constant r. R is just a real constant. Do we, do the one not involving R first? Okay. So I'm thinking like the R is kind of a problem, right? See if we can figure out, okay, the set over there. So is this going to be... you're gonna have like an infinitely long line starting from the origin and going out at an angle at 3 pi over 4, or maybe with an offset because of the -2. Does it change? Okay. Make it a bit smaller. It's the line you drew on the diagram? Really? I didn't imagine it to be drawn like that. I might be wrong though, because this isn't my specialty. I thought it would, I guess there is the offset. But like okay, so like by default, 3 pi over 4 is a 45-degree angle that way. Going out like that, I would think. So I don't think we do the other end. And then if we have z minus 2, we shift it on the real axis to the right by 2? I guess that makes sense how you got that line. Okay. Okay, I think I see how you got that now. And you did the dotted line for the other part. Does that make sense to me at least? One, two, let's just say. 1, 2. Draw a few more tick marks. Half line. Okay, yeah, that makes sense. Or maybe, I think in geometry I learned it as like a array or something. I don't know if that is usually used in complex variables though. I mean, I guess it'd be where the circle intersects the line. But, so I guess we could get the minimum and there shouldn't be a, no, there has to be 2 solutions. So we could try to find, if our circle is centered at 3, 5, I guess we'd want to find, we're gonna have one case where the circle's just big enough that it hits the line once, which doesn't count because we need it to hit twice. And then we have another case where the circle goes around this point and does hit twice, but any bigger and you're done for. Because now it's gonna go off the edge of that part that we cut off. So I think we need to find what radius goes from the center to the line, like at the minimum, and then from the center to the, I guess, end of the line there, which this one will be much easier because they, well, not really. Actually, yeah, this one is still easy because we actually know what this point is. From the point to the line, we have to do a bit of math. Okay, I feel like we can reduce this like a normal algebra problem now, I think. So wait, Thunder, does that make sense with like the 2 circles, I guess, before I go off into the weeds of trying to solve this? Like what we're trying to do? Oh. Because we're trying to find, well, the answer we want is r, so we need to find the radius of these two circles. And we already know that this is the point, you know, I'm just gonna say it in normal Cartesian coordinates. Hey, Brian, yeah. This is the point 2, 0. And we can find the distance from 2, 0 to 3, 5 just with the distance formula. Find the minimum distance from the point to the line. I always forget how to do that. It's not that hard. I just always need to remember how. You draw the perpendicular. Dude, I don't know why. Oh, Brian. Thanks so much for the 28 bits. I just marked my chairs that hold up my whiteboard. Give me 1 second. I appreciate that a lot, Brian, though. Thank you. Actually, I'm just gonna leave this paper towel here too, because I'm sure I'm gonna mess up even more. Okay. Orthogonal vector to the line. Oh, yes! We get the slope of the line, find the perpendicular. Or, you flip it and negate it to get the perpendicular slope, and then you have a point in a slope. There we go, that's how you do it. Thank you, Zach. Okay, but first, I will do the one that I said first with finding the maximum. Our max is going to be the distance formula with roots. I'll take this as my first point, that as my second point. So x1 minus x2 squared plus y1 minus y2 squared, square rooted. 1 squared is 1, 5 squared is 25, so root 26, I think. And scale appropriately. Oh yes, Pensive, that's a good point. This is an inclusive upper bound. And actually, it's 2r. You're completely right, Thunderfix. Great catch. 2 times r max. Squared, right? Do we have a double square root? No. I think I'm making that too complicated. I was thinking about the equation for a circle. No, I think it does, because that point is inclusive, right? Or does it? Oh, ooh. Does the 0 point count per arg? Maybe it doesn't. I guess that's true. It is. I guess it's every possible. It's like, what's the angle of the 0 vector? Okay, yeah. Depends on how you define it. Yeah. That might be one to look up. So I'm not sure whether we should include it or not. And actually, we don't need to square root it again because we already did the square root here. I always forget the distance formula is just the equation for a circle. But so we did the square root here instead of having the squared there, so we're actually fine. We can just say our max is root 26 over 2. And that's fine. And then for the minimum, and the inclusive exclusive part, I'm gonna have to Google, I think, just about the arg function. If that's always true or never true, I guess. Or if it depends on the context, maybe. I don't know. And then we want to find the distance from a point to a line. So the way that I know to do this is you make a perpendicular line with this one, because I'm just doing this like the algebra way. You can find the slope of a perpendicular line just by flipping the slope and negating it. Here our slope is basically -1. So the slope of this line is +1. So we have a slope of +1 and a point that we're given 3, 5. So we can do, if y equals x plus b, we can plug in for y and x, because slope is 1. I'm not going too fast in this part. 3 plus 5, b equals 2. So it actually is that point. That's interesting. So the equation of the perpendicular line is y equals x plus 2. Hey, Central. Yeah, Brian, the problem is posted there. It's basically if r is a real constant, what is its range? It might be a bit hard to read, so I'm sorry if it is. And then we want to find, I guess, where y equals x plus 2 in that line, I'm treating as y equals 2 minus x intersect. I mean, it's going to be at that 2, 0 point, but we should actually show that. So we set x plus 2 equal to 2 minus x. Add x to each side, 2x equals 0, x equals 0. Okay, so it is at 0, 2. Then we can find the distance from 0, 2 to 3, 5, and that'll be the minimum. So I don't want to get covered up. It's going to be a little bit squished. Let me just go over to the other side, because I don't want to write where the problem is. Wait, I did something wrong? Y equals minus x plus 2? That's the same thing as that. That's 2 minus x. I'm just talking about something else. 2 minus x and negative x plus 2 are the same thing. Wait. Oh no, so I set them... Oh yeah, so... yeah, the line that you also have in your drawing is 2 minus x. Like the solid line. Same one that we both have. And then the dotted line that I drew is x plus 2, because that's the perpendicular. And I'm sure there's a cleaner way to do it that Zach was probably saying, but this is the way that I know how to do it, so... Okay, cool. So I use that perpendicular line to get the, basically, the distance from the point to the actual line that we wanted. Well, we're about to find that now. So we'll do the same thing. 2r min. Right? Yeah. Then distance formula with 0, 2, which I'll take as my first point, and 3, 5. So x1 is 0, x2 is 3 squared, plus y1 is 2 minus y2 is 5 squared. That's like an s. 9 plus 9 is 18. So that's 3 root 2. Our min is, we divide by 2. 3 root 2 over... Wow, how many fraction bars do I need? And we do need to figure out if they're inclusive or not inclusive. For that part, I worked it out because I found out I basically took the center of the circle and drew a perpendicular line that was y equals x plus 2. And then I figured out where y equals x plus 2 and y equals 2 minus x intersect. So there it did happen to be on the y-axis, but I actually did the math here to not make that assumption. So I set x plus 2 equal to 2 minus x to figure out where they intersect, and it happens to be at x equals 0. So we got the minimum and the maximum, but I still don't know. The minimum is certainly not inclusive, right? Because the minimum is that case where it just intersects once. And so I think the minimum is not inclusive. I think you need to reverse. 3 root 2 over 2 is the smallest one. And the root 26 over 2 might need to be or equal to. That part I'm not sure about. Arg0 is undefined. So in that case, yeah, I would say we don't need the or equal to, I would think. Thanks for looking that up, Penn Center. Let me put my mug away because I'm out of tea now. Kind of a fun problem. If I didn't have the setup that you had, though, I don't know if I would have been able to do it if I wasn't given like this information, because I'm not familiar enough with complex variables.